But now for something completely different, if you will, we're going to get closer to deploying. So when we have this web server like Nginx, and maybe some other applications like some kind of database that your web server is communicating with, we need to serve it on a system, and it needs to be on some operating system. And what we're going to use is something called Docker and Docker Compose to serve these applications in a operating system agnostic way. So once we have Docker, we're going to be able to serve these things regardless of what operating system you use, which is useful so that you can develop it on your system, say Mac or Windows, and then make sure we can run it when it gets to the server environment, which is likely going to be running Linux. So for this, we'll use Docker. And what is Docker? So Docker will package an application with all of its dependencies, so whatever it needs, in this loosely isolated environment called a container. And based on this like declaration file called the Docker file, again, once we've done this, we can run this application anywhere, any operating system, locally, in the cloud. And Docker gives us, because it's packaged and in one bundle, if you will, there's also something called Docker Hub, which is really just a repository of these Docker containers that different people in the community have assembled. And so you can get from Docker Hub web servers, databases, and other applications that have already been Dockerized and will run on any platform. And Docker Hub is at this link, and then this is the link for Docker documentation, which will be useful for installing it and using it. So as an example, we can build a static web server. So using this Nginx on Docker Hub, you'll find Nginx at this URL, and it gives you some useful README on how to use the image. And one way to use it is to create a new Docker file, which will be based on Nginx itself, the web server. And all you do is you copy some static HTML, for instance, like this website that I created here, and you just put it in this specific directory. And Nginx in this Docker container has already been configured to host this web server from this directory. Nginx and Apache both use this convention where files that are .html, index.html will appear when you visit like a directory. So if you go to get slash, and you don't have to put index.html, you can just put slash, and then this document will be served to the user. So if we do this, if we make this Docker file and then build it, we will have a website that lets you click it and hide things. A more elaborate Docker file might, instead of using a static website, might do a dynamic one. So this example Docker file is serving a Python web application with Flask. And so on the right here, we can see this is how you would build a basic application in Flask. You would import this Flask, and then you can route from slash to this function. And so we'll just return hello world in the function. And Flask has a lot more docs behind it, but this would be the hello world of Flask. Then you need to have Flask and Unicorn installed to run this as a HTTP server. And then to serve it with Docker, we'll start from the Python 3 image, so that Python is installed on and everything in the Docker image. And then with Python being installed, all we need to do is add our dependencies and install them. That's what this does here. So copy is just taking some file from our system and putting it in the Docker container to be packaged. Run will actually execute a command in the Docker container, not on our system, in the Docker container. So this effectively installs all the dependencies in the Docker container. Then we'll add the rest of our source, which is really just the app.py. We expose port 80, and then we use this Gunicorn service to actually serve the Python app itself. And so Gunicorn just handles speaking HTTP, right, as a web server, and then translating get paths into Python calls to functions. Then it takes the returns and then it translates those back into HTTP returns. So, these three files, if you would create them and then put them in a directory, you could build this Docker file, and then again, you'd have another Docker container, which could be deployed as a website and used publicly. So here are some useful Docker commands. Again, with both of those two, if you were to put them in a directory, this is how you would build them. You, after installing Docker, of course, which you can consult with the docs for, you run docker build -t gives some kind of tag, a name to your Docker container, which is of the form username / some name for the application, and then : some version tag. And then this dot just says the current directory. So you would run this in the directory that you created. And when you do this, this tag then becomes available from your system. And if you want to make it available from outside your system, you can run docker push with the same tag. And this will push it to Docker Hub so that it can be pulled by you or other people as well, and run on those other systems. To run a Docker container that you've compiled with build, there's this run command, and there are a number of flags. One of them is this -v flag, and the way it works is that the directory on the left is your system, and the directory on the right is the system of the Docker container. And so pwd is just a shortcut to the current working directory. And then work will be the path in the Docker system. So if there's some file in your working directory, if you're in the container, like some application is running in the container, it can access that file at /work/ whatever the file is. And I put in a link to this Docker cheat sheet, which has these commands and several others just for day-to-day using Docker. But this is the gist of it. The next thing I'll discuss is Docker Compose. So Docker is for assembling one application into a container, and then Docker Compose lets you assemble several applications into several containers and just manage them jointly. And so it's typically used in a larger application. Many web applications require maybe a server, a web server. They may require a database, a companion database, and they may require other services. And so you can specify each of those services in a Docker Compose. And they set up these cross-container communication. So essentially treating these containers as if they are their own machines. These containers can make requests to other containers. And the Docker Compose very easily sets up these local isolated networks so that the containers can communicate with one another. And then some of these arguments, like the one I showed here, this -v, can be baked into the Docker Compose specification. A -v would go under this volume section, which I'll show in a moment. And there's other parameters that you might need to put in, including environment variables and expose ports. Again, the docs for Docker Compose are linked here, and they have a more detailed guide and usage instructions for Docker Compose. This is an example Docker Compose. So all Docker Composes will have a version, and then there's this services, and each item in this map is a different service. So this one we're calling app, this one we're calling DB. And basically you can specify your tag under this image, or for instance, if we're using a public image, like for instance, this Postgres version 12, we can put that image. Then here we have environment. So a lot of times, if you're going to be using a database, you would want to configure it via a environment variable. And so this is just an example of specifying this database. So Postgres is the URI, the scheme. Then we're saying the username is Postgres. We're going to use the same Postgres password we specified over here at DB. So this is the host name of the database, and we'll use the same as the service name as defined in the Docker Compose, and then in this Postgres database. So now when we do this, our app is going to have access to this URI, and then it's going to be able to connect to this database that is running alongside it. Another thing we have is the ports. So remember that 80 is HTTP. So now what this is saying is I want my host system 8080 to be routed to, if you will, the port 80 of the container. So the container can be serving port 80, and then when people visit our server, they're going to need to go to 8080 because of how this is defined. But you can also just specify the port, and then this will do, it's equivalent to 5432:5432 for accessing this database remotely. Finally, we have the volumes. So in the Postgres docs, this specific volume is where Postgres would save all of the data. So to make it persistent, we put it there. So this kind of is how a Docker Compose YAML works. All the different services you need are just there line by line. And then to use this file, we use this Docker Compose command line. And then we can just say Docker Compose up -d, and this will run all of the services defined in the container. If it needs to pull, for instance, Postgres, because it's not available, it will do that. And we can also use this to build. And notice we no longer have to do -t and specify it because it's already defined in the Docker Compose file. And we can also look at the logs when it's running and other things. And finally, if we're done with the Docker Compose, we can put it down, Docker Compose down, and then this -v flag is a useful one to know. So this link has another cheat sheet for Docker Compose commands that you can use. But yeah, I typically will end up using Docker Compose alongside Docker, since many applications just require multiple images. So just to kind of wrap up with this segment for Docker and Docker Compose, what Docker is giving us is that in the past, which you guys don't have to do because you're being introduced to Docker now, you would develop an application and then try to put it in a production system, which served the database, served the web server, has served a bunch of other stuff. And sometimes that worked, and sometimes it didn't really work the same way. But in the Docker ecosystem, your application includes all of these things. You know, whatever web server you're going to use, whatever database you're going to use, all of the dependencies you can work on in development. And then when it's ready, you can put it in production on a server. And in our experience, maintaining many different bioinformatics web applications, this vastly simplifies things. So, are there any questions at this point before I move on?